Well, hello everybody. Welcome into the Great Atmosphere Show here on January 10th of 24. Got a lot to talk about today, but before we get into it, I want to remind you to make sure to hit that subscribe button. I specifically make synoptic and mesoscale based forecasts for the southeast region of the United States, mostly just for my benefit and to help myself get better at communicating the weather. But ultimately, there's no point to not subscribe if you are in that region and just want to know a little bit more in depth beyond your typical broadcast meteorologist knowledge. So definitely subscribe. Today we're going to be taking a look at what we saw yesterday with our pretty significant storm system that moved through pretty much the entire depth of the eastern seaboard. We'll do a mini post-mortem of yesterday's storm. We'll do a proper synoptic analysis of Friday's storm that's coming our way here in just a few days. And then we'll see if we have anything to look forward to as far as odd temperature ranges or perhaps even a wintry outlook for early next week. But first, we'll take a look at our satellite view of the contiguous United States. You can see here in the southeast, pretty much crystal clear blue skies, high pressure starting to build in and dominate, some lingering fog in the Tennessee and Ohio River valleys. That'll be there for the majority of the early to mid-afternoon. We see gravity waves dominating the Virginia Piedmont and central Pennsylvania regions. That's kind of the atmosphere's way of depicting cold air advection. We have cold air coming down from the Great Lakes in accordance with that high pressure, and as it descends off of the mountains, has a little bit of a hard time mixing in with the warm oceanic air mass that it is about to encounter, and that's why you get these cloud streets in that particular circumstance. We also see the aftermath of the Great Plains blizzard that occurred over the Central Plains states in Kansas, Nebraska. Iowa got completely decked, and South Dakota. And then we see pretty much the entirety of the Pacific Northwest is white. They've been under pretty much an ongoing blizzard warning for the majority of the past 72 hours. Does not seem to be stopping either. They're going to be having some crazy snow totals to see at the end of this all, whenever that happens. And even Northern California is getting its fair share. Up in the Lake Tahoe region, they're definitely contributing to that snowpack quite considerably. My wife and I took a trip earlier on in the year. We wanted to go from San Francisco and drive all the way up to Seattle, seeing different places along the way, such as Crater Lake. We actually tried to time it with the lunar eclipse as it was occurring, the annular lunar eclipse as it was occurring. Hoping to see that over Crater Lake, but unfortunately, high clouds dominated, couldn't really see it. But we got to see Bend, we got to see Yakima, all the Cascadian Plateau, Mount Rainier, and eventually up into Seattle, which we loved. That whole trip, if we were to do it now, would be an absolute nightmare of a of a driving vacation. I will say it's not looking great. So that's the satellite view of what we're looking at. Taking a look at water vapor, you can see that we do have, and this is in the mid-levels, dry air for the most part dominating the southeast with some upper-level high cirrus clouds in place. You can see those little cloud street perturbations right there. A little mini low that's going over Nebraska at the moment, not producing a whole lot in terms of precipitation or forcing, but ultimately just kind of spinning out there. And then we have our big Rocky Mountain storm system that is continuing to blow through. A little atmospheric river event an atmospheric river winter edition that is making its way through that region. Taking a look at radar, you can see that our system is finally moving out of New England at the moment. Going to cause a little bit of problems for the upper elevations in the Mount Washington region of New Hampshire and the top of the Mitten in Maine. You can see that those light snow showers that are moving through the Midwest right now, and a continuation of the snow and the rain that's currently hitting the coast, the Olympic Mountains, and the Cascadian Mountains, and also quite considerably there. You got a pretty big dig in the Snake River Valley of Idaho going into right there. But other than that, precip is relatively calm throughout the course of the rest of the U.S. Taking a look at our current temperatures. You can see don't want to be in Canada at the moment. Everything is, generally speaking, with the exception of southern Ontario, as per well below 0 degrees Fahrenheit, which is quite considerable, obviously. And then we have our Rocky Mountains uh, contributing to that obviously snowy condition underneath that 32-degree mark, and the Midwest in the 20s, contributing to those snow showers. Low to high to mid 40s, mid 50s max in the southeast at the moment. Relatively cool, I think that's about 2 or 3 degrees below average for this time of year. At this time of day here, it's about 2 o'clock in the afternoon here on the eastern seaboard. Taking a look at our National Weather Service all hazards map, you can see kind of the aftermath of what occurred yesterday. Turned out to be a much more significant rain event than it was a severe per se event. Rain and wind, I will say, were the two major, thankfully, the two major issues that occurred over there in the southeast and the mid-Atlantic yesterday. There was a major concern, obviously, for tornadoes, and we did have a few tornadoes, but none were strong, and I believe there was only 1 or 2 fatalities. I know of one specifically that was in the North Charlotte region, and then I believe there was another one somewhere in the South Carolina, Georgia region, not entirely sure, but honestly, the panhandle of Florida with landfalling waterspouts early in the day on Friday was the main issue. And then, as you can see, all of these are flood warnings, and you can see they're a little oblong and whatnot. They're not really following a county line. That's because they are following riverbanks. So you can see here as the soil is refusing to take any more any more rainfall. I mean, some rainfall estimates in a lot of places had over 3.5 inches of rain. I know in my particular weather gauge outside here in Charlotte had 3.5 inches. The closer you got to the mountains, the higher the amounts you saw. Yeah, here we go. So this is the last 72 hours of precipitation. Major training happened here in central Georgia, south of Atlanta, and the Montgomery region of Alabama, southern Mississippi, and the typical in the typical places that you would see high rainfall due to upslope isentropic lift would be in the western North Carolina mountains. You can see they've received 5-6 inches of rain. Typical for that temperate/rainforest region, and also the upstate of South Carolina. That was a main area of concern yesterday as well, in that Greenville-Spartanburg region near Greer, Malden. That particular region received quite a bit of rainfall, and I believe some of those rivers definitely broke their crest going into yesterday. And we talked about this yesterday. I have no idea what it is with this area, but as I was talking, and if you didn't tune in yesterday, I used to work with the National Weather Service in Columbia very, very shortly. It was just an internship, but one of the things that I had to do was I would go back and see different severe weather events that occurred in the region over the course of the past 10, 15 years and look for patterns. And one of the big patterns that I saw is that if you were in Bamberg County or near Orangeburg in South Carolina, which I don't know if I have a specific map here. Yep, here we go. This general region, you just get hit with tornadoes. And I don't know why. I'm sure there's probably someone at USC, hopefully, that is doing some semblance of a dissertation right now on the Bamberg-Orangeburg tornado phenomenon. But look, I mean, there were other spin-ups, little tiny tornadoes. I know there was one here that landfalled. It was a waterspout that landfalled that went into the western Wilmington area, and then there was definitely a tornado warned cell up here in Catawba. And then there was another tornado warned. I believe it was mainly radar indicated in the Matthews Mint-Hill region of Charlotte. That's just what I know. But there were other places definitely earlier on here in the eastern Georgia and central South Carolina basins. What do you know? The one place you would see it was downtown Bamberg, like right there. And it was pretty sad just because, Bamberg, obviously not the most economically healthy community by any means. Its best days were behind it, but a lot of these I like driving through old downtowns, and unfortunately, and it's not the biggest town by any means either. It is the county seat, but it's not huge by any means. And a lot of these buildings got completely destroyed with the course of this storm. If this were to happen back in the 50s, this would be a particularly devastating event, but obviously I haven't heard of that anybody was hurt here. Just kind of odd for it to be so right on the money like that, Bamberg getting targeted as such. So looking at the total storm reports for the day, definitely the main headlines would be wind, as we expected, um, with one heavy precipitation one, and then obviously we had our big tornado outbreak that occurred here in the Panhandle and far southeastern Alabama and far southwestern Georgia near Albany. But that was effectively it. There was one here, an EF0 that occurred in the St. Petersburg Peninsula of the Tampa region. But other than that, we just had major winds. So we have trees down, power lines. Let's see, trees down. We got more trees on power lines. That's kind of just what it was. I know we had our fair share of trees that fell here in Charlotte. That was kind of the main story going into yesterday. And we'll see. And as the National Weather Service, they are responsible for producing these storm reports and doing damage surveys. They will add to this list, and there will probably be more tornado reports as we go on during the week. But ultimately, this is what the user reports have amounted to going forward so far. Taking a look at what we are expecting here, I believe that we're going to look at kind of the temperature-wise, what we're looking at temperature-wise here. So this is currently where we're at. Pay attention more to the colors than necessarily to the temperature values. This is today at 1 p.m. This is a little bit off. So actually, I'm going to put this off for now. So a lot of people were asking why yesterday's storm was not a big wintry event. And for the most part, it has to do with the fact that in order for a low pressure system to ultimately draw in enough cold air and moisture, it needs to be able to originate here in the central Texas region, dip below the Appalachians, or just maybe skip over the Appalachians temporarily, have a high pressure center up here that can draw in cold air from the north, create a cold air damming situation against the Appalachian Mountains. The moisture return comes in from the deep south and from the Gulf, and the end result is a wintry mess. That is not the case. The low pressure center originated from the Central Plains and then made its way up into New England. It bombed out here over the Midwest, I believe. Actually, I believe it was Indianapolis, the National Weather Service office there. They set a new low pressure record, like lowest pressure they've ever seen from a storm system. I believe it was 972 millibars, if I remember correctly. Pretty big, severe disparity in pressure isobars, and that is what attributed to having such significant wind gusts yesterday, because obviously air itself is going to move from areas of higher pressure to lower pressure, much like if you were to release the air from a tire. Inside the tire is obviously very highly pressurized air. You take away the cap, and then all of a sudden the air goes one way. It goes out to areas of lower pressure. And that is the exact same scenario that happens here. So we had high pressure that was off the coast and just hanging out here, or just not even higher pressure, just lower pressure than what was centered over here in Indiana. And ultimately, the air made its way from the southeast to the northwest in that general direction over the course of the day, and that's ultimately what caused all the wind damage, because it was such a severe pressure gradient change. So, taking a look at what we're going to be seeing here in the next few days, the next main system is going to be on Friday. This is where the Euro ensemble is assuming for that low center to originate. And it's looking like, well, there's actually quite a bit of disparity. It's quite odd, honestly, to me, that there is this big of a range. This is a few days out now. They should have a better understanding. But ultimately, it's starting here in the Panhandle. This is a Panhandle low setup. And what happens at a Panhandle low is typically it'll come off of the Rockies with adiabatic descent, and then deepen a little bit, create that first low center. Go south, probably along the Red River, just for a little bit, and then it'll zoom right off up the Ohio River Valley and deep in here, typically what we saw yesterday, up into the Erie, Ontario region before making its way there. So ultimately, we're not going to get that Miller Type A, Miller Type B system set up where we could see anything wintry for the southeast. We don't have high pressure here filling in, so we don't have any cold air filing in from the north. Certainly not a setup which would contribute to anything winter-wise in this scenario. So what we do have here is, as you can see, yep, as expected, we have another bomb. Wow, gosh, it just loves to bomb out over Indiana, doesn't it? 972 over Central Michigan. How about that? But we see the general track and what's going to be here. We see the main trough going to be digging here in central Georgia and then making its way. And this is where you would expect the cold front to be before it makes its way out of here. And you can generally see, obviously, low pressure centers move in a cyclonic formation. It draws the moisture up and out of the Gulf, and it will subsequently fill back in on the back end a lot of cold, dry air from the northern plains until it finally goes out to sea. And this is what is going to be interesting going into the next days after Friday, mainly into the weekend. You see it left a huge channel of high pressure ridging originating from way up in not only the polar regions, but the Arctic regions. This is a straight channel of Arctic air that is going to be making its way down into the United States subcontinental region. And for areas that are directly impacted by it, specifically that in the plains and even in some areas such as Texas, they could be seeing lows that are going to be quite significantly lower than we would expect here for this time of year. It's a cold snap, essentially. Taking a look at how the main flagship models have been performing as of recently, and with this last system, 95th percentile for both the Euro and the GFS, so they definitely have gotten their act together a little differently than how they started the year, but we love it when they do well, so that is a good thing. So we're going to take a look at what they're expecting from a timing-wise perspective. You can see that low center, and I will say we're a southeastern show here, but if we were a Midwestern show, we would be very concerned about the snowfall potential and that rain-snow line here in the Midwest. This is a ton of snow that this area has been getting recently, so we have to be cognizant of that as we move forward for them. It's going to be one of the more significant winters already for that region. And we can see this is about 6 p.m. on Friday. It's pretty much already shipped out according to pretty much both models. And what's good to see here is models are both performing very well and they're in general agreement as in just a few days out, which is a good indicator that we have a good baseline knowledge to work forward. And it definitely helps us out in terms of decision support services if we were in the emergency management division anywhere, which I'm sure that they've already put out their right effective guidance. So let's get a little bit more analytical as far as what we're expecting here for this upcoming Friday. Some of the parameters that we look at when we're looking for severe weather, one is bulk shear. Now, shear is ultimately one of the main contributors to characterize a strong storm system. In order for a storm system to begin to spin and properly convect, there has to be differences in wind speed and wind direction between the lowest levels at the surface and the mid levels in order for actual cellular thunderstorms to be able to form. So what we're seeing here is we definitely have no shortage of shear as we move forward. This is, let's see where we're at. We're at the prime time for the storms will be, we'll call it mid-afternoon-ish on Friday. So we can see here we're at about 98 knots in that general range. That is specifically perfectly fine. That is conducive for supercell development. It does not mean that supercells are going to develop. It just means that if all of the other parameters were in place in that sense, we would be a-okay. Usually for supercells, we're looking at like 40 to 60 plus knots. So we are well over the threshold for that. For a multi-cell system, probably about 20 to 40. Anything less than 20 would just be little single cell storms. Typically, you see those in the summertime that are for storms that are more convection based than they are shear and synoptically forced based systems. So that's bulk shear. We can take a look at mixed layer CAPE. CAPE is essentially what your local broadcaster will refer to as thunderstorm fuel. There's different forms of CAPE. The one that I typically look at the most is mixed layer CAPE. Mixed layer CAPE specifically is computed using the lowest 100 millibar average temperature and dew point observations. So it's usually most realistic for convection that's originating near the surface, which is most convection in most cases. There is some circumstances where you might want to use the most unstable CAPE if you know you have a really high cloud deck that you have to deal with. So you're looking for elevated convection, huge cumulonimbus thunderstorms, that kind of deal that you might see in the summertime. But in this scenario, mixed layer CAPE will do the job just fine. And this is why we're probably not expecting a major severe threat over here in the Ohio River Valley, even though you saw accelerated bulk shear values here in Tennessee and whatnot. Not a lot of juice for a lot of systems to originate, in that particular region. But we do see it in central Georgia, we see it in central South Carolina, and we're going to see it in the coastal plain of North Carolina as well. We can also take a look at some other parameters. We're going to look first at storm relative helicity and the 0 to 1 kilometer region. This is typically a good indicator for any spin in the lowest sectors of the atmosphere. Generally speaking, a good indicator if any particular tornadoes were to appear. Now you see that there's a lot going on in that Ohio River Valley region as far as storm relative helicity, but we do not have any juice in that region, nor do we have a lot of moisture return either. So we would expect not a lot to get started in that region, but there is a little overlap here in the central Georgia, central South Carolina, and probably in the Currituck regions and the far northeastern Elizabeth City, New Bern regions of North Carolina. Something to keep in mind there. Then we can look at energy helicity index. Generally speaking, another good opportunity for supercell formation. And yeah, it seems to want to favor central Georgia again. Not as much in South Carolina, but certainly a little bit in North Carolina. So definitely we're going to be on the lookout for discrete supercells that produce long track tornadoes with that going into Friday. But ultimately, the main story I probably should look at here first is timing. This is the 12-kilometer NAM. Does a pretty good job of understanding when this system is going to hit and when it's ultimately going to ship out. So we see that beginning of the deepening starting in the plains. It's actually going to be a very, very quick and short-lived system. Making its way up through the Ohio River Valley, you see that frontal passage starting to form here in the deep south. Before it comes in, we'll see in Georgia, we'll see rain start to originate. We'll see those little dots of discrete cells occur Friday morning. All the way through Friday morning would be the general start, maybe mid-afternoon for the Carolinas, before most of it's gone by 6Z Saturday. It's overnight Saturday. So it's a 18-hour system. Not a lot to write home about in that particular region. One other thing we have to pay attention to is the moisture return for this system. Now, that, as we said before, the main problem from earlier in the week on Tuesday, yesterday, was flooding. And that is the main reason why we saw so much flooding, was because we had huge precipitable water values throughout the course of the atmosphere, and also high dew point values that stayed there over the course of a full daytime heating cycle. So it was hot, it was moist, and everything was there for deep layer convection to occur. In this scenario, that is not the case. So we see what time we got here. So this is midday, or this is middle of the night on Friday, and we still have dry air that is centered right on top of us. There is not a lot of opportunity. No one's going to be sitting in moisture for multiple days ahead of this system. The only first time that dew points really start to come in would be right as it comes through. So there's not going to be a lot already in place. So there's, generally speaking, not probably a significant threat of flooding. There is still very high values here, and probably for the cells that do hit, and for the squall that forms, it'll be a pretty significant amount of rain in that time frame. But as we said, it's moving relatively quickly. There's not going to be a huge rain shield with this, as we saw on Tuesday. So I do expect flooding to be maybe, we'll call it one third, maybe even a fourth of what we saw. Just your typical, I would say, low pressure center system storm in this particular scenario. And then you see that dry tongue just starts to whoosh, just kind of, waft everything out to sea. And then after that is when the cold and dry air from not only the polar regions, but the Arctic regions start to make its way. We're not going to have Arctic air per se here in the southeast. Our air modifies itself over time. It doesn't just stay at 0 degrees and then make its way here and it's still 0 degrees. It has to travel, and the warm air that it encounters ultimately warms it up as well. So we'll probably get down to the mid 30s, maybe mid 20s for lows here in the southeast in some states, but ultimately still very, very cold as the system moves on through. We can also take a look at what we're expecting from an energy point of view. This is the 500 millibar vorticity, and I wouldn't pay so much attention to the different colors and whatnot. Mainly, we want to pay attention to these little tiny short waves, these little perturbations that we see in the isobars. Ultimately, or in the heights, I should say. Ultimately, these are what are going to dictate our triggers for storms, and the more significant of a shortwave that we see, particularly in areas that we're expecting, we have all the other parameters in place because we want overlap of those parameters we've already talked about. So we don't want to pay attention too much to the perturbations that are occurring here in the Ohio River Valley, because we know that those parameterizations are not favorable for storm system development. Ultimately, we want to look at what's going on in the areas that we do. And we see these perturbations occurring here in central North Carolina, and also in the upstate of South Carolina, and some in central Georgia, as we've seen. So what does that all amount to? Well, what do you expect? The severe weather outlook from the SPC is already given out its day 3 outlook for probability of severe weather. If you were in the red, you have a 30 to 44% chance of severe weather within 25 miles of a point within. And then if you're in the hatched, it is a greater than 10% probability of significant severe weather, which can include an EF2 plus tornado. So keep that in mind, and you can see that the coast, generally speaking, is not under the gun as much as the central regions. Now, interestingly enough, they did include central Alabama and Montgomery in this. We'll see if they backtrack on that, but I would actually expect them to move this a little bit further up into the northeast based off some of the guidance that we've seen here today. Could be wrong. I am certainly not a severe weather forecaster by trade, but that is just by expectation of what we have seen currently. I will actually say it's a little bit of a tell that they have extended this 15 to 29% range as far west as central Mississippi. Perhaps I'm wrong on that. We'll see tomorrow if they decide to change. They don't give their categorical outlooks until day 2, so we'll see specifically where they anticipate tornadic threats. I would not expect any hail threats from this system due to the fact that hail requires minimal shear in order for it to regenerate itself in a convective cloud base. So I would expect this mainly to be a wind event based off of the deepening low that we'll see in the Midwest, and a tornado possibility in the central regions of the South Atlantic states. Also, we're going to take a look at the flash flooding potential. As we saw in this earlier graphic here, not a lot of moisture return in this particular system. It's going to be dry throughout, pretty much up until the very moment that the storm system makes its way through. So we can expect not necessarily much in terms of rainfall, except on the eastward-facing slopes due to isentropic lift. Now, what is isentropic lift or orographic lift? It essentially means let's see if I can draw this out in a relatively easy way. So let's say we got mountains, right? And we got little tiny mountains like foothills. And then here we have the top of the atmosphere. Okay, this is the full depth of the atmosphere, right? Now, let's say this entire depth of the atmosphere is like a sponge, right? the depth of the atmosphere stops existing when it encounters land, because the atmosphere cannot exist where land is. Obviously, that's land, that's mountain, not air. So the atmosphere kind of gets squished. Okay? So that sponge, much like you would do in this scenario when you're washing dishes or something like that, you put pressure on it from the bottom, and ultimately a lot of moisture would end up coming out, because the amounts of water that chunk of atmosphere can hold for the full depth of the atmosphere, it might be able to hold it in the sky because there's just enough room for it. But there's not a lot of room to hold all that same amount of moisture, that same amount of water vapor when you get up into the mountains, and thus that has to go somewhere, and it goes into those eastward-facing slopes typically. And that's exactly what we see here. Not necessarily a reflection of the high amounts of dew points and high low-level jet or whatever it might be, but ultimately it's just these are higher elevation areas, and that's going to behoove itself to create a more of a flood risk. And those areas are very, very saturated. So even still, even if it's a marginal flash flood risk, we still have to be mindful going into Friday. Yes, so that is that. Let me get rid of this somehow if I can. Don't know if I can. Let's see here. What do we got going on? I think we're done. No, we're not. Now we are. Okay, great. So moving forward just a little bit here, let's look at that. We mentioned earlier the temperature returns and that Arctic air that's going to be moving in. Ultimately, this is kind of a good understanding of what we're expecting over the next couple. So you can see here, this is where we're at earlier in the week. Relatively warm. We're in the 60s, whatever this might be, and then whoosh. Behind the low center as it comes through, you can see this gradual shift of cold air across the course of the whole country. That is ultimately driven by what we were looking at earlier with the synoptic forcings based off the low pressure centers. You can see that high pressure channel just opening the way, opening the floodgates for cold air to come in through. And that's why the Weather Prediction Center, or the Climate Prediction Center, has put out a hazardous temperature, high risk for much below temperatures, higher than 60% chance on the 17th, which is well beyond Friday, I will say. What day is that? So let's do, it's midweek next week. So this is here to stay, right? And, obviously not great. This would be a major problem here for people that have challenging power grids like Texas, and also for areas that are unprepared for such things. Usually if you don't have a home heat generator, or you get stuck on the side of the road when it's below 10 degrees. I mean, this is life-threatening stuff in some respects, or it's definitely something that people are not used to. But for us, when we want wintry precipitation, just maybe once, cold air is good. So cold air in place is one of the ingredients that you need in order for snow to occur. Only two other things you need are moisture, and you need the energy forcing to be able to kick something off. So we'll be looking forward to that. Now, there was a little bit of a theory, I will say, earlier on put out by the Euro model earlier on in the week, that we might have something icy related going on here in the southeast going into next week. That seems to have not materialized. This is our snow from the GEFS ensemble forecast. We'll go through all the way through next week. Mainly mountain snow. We see our big Midwest values and Southern Canadian, our typical regions that we have already seen snow. And then we look at the ECMWF, the same model that we saw earlier in the week. They are still very bullish, and I still am in agreement as well that northeastern Texas and southwestern Arkansas, kind of the Arklatex region, literally the Arklatex region. Dallas specifically is particularly under the gun for probably a major icing event. But then you move forward through time, we'll see essentially for the rest. But remember earlier in the week, this was a more central Piedmont, Virginia, South Carolina, North Carolina thing. Now that has shifted off to the northwest into the mountain regions. So doesn't look like much. And as far as moisture return as well, we don't have that in place. It's just going to be a lot of cold, dry air. and that particular pattern of panhandle low is going to be kind of the modus operandi going forward anyway. So SADS, unfortunate that we're not getting anything here in the Carolinas snow-wise at the moment. My bet is still going to lie in the late February, early March area for our best chances climatologically, but we can get to that a little bit later on, perhaps in a different video. But that will conclude us for the day. Once again, my name is Zach from Great Atmosphere. I appreciate y'all tuning in. Please be sure to subscribe, and I'll see you tomorrow with some more southeastern weather analysis. Have a good one. Bye-bye.